All right, welcome, ladies and gentlemen, to section 3.3. We're looking at polynomials and synthetic division. We're going to do some long division as well, so we're just going to have to hang in there and do a little bit of everything today. Now, you might remember some of this from your Algebra 2, so some of it might look a little bit familiar to you. So let's start off with long division. It's called a long division algorithm, which is what we want to start with. And what we want to start with is just some numbers. We're going to be writing our answers in a few different ways. First of all, before I get to the numbers here, we're going to write our function as the product of two functions plus the remainder, or as the division, the f of x divided by d of x, is equal to whatever the answer is plus our remainder over the original denominator. Now you'll see what I mean as we continue forward. Just have this handy as we continue. So let's look at 237 divided by 7 using simple long division that we learned way back in 3rd grade. Now we know that if we do 237 divided by 3, that's going to look like 237 divided by 3 is going to equal some number plus the remainder. And we did this way back in the day, so let's go ahead and see what this is going to be. So if I do 237, divided by 3, I need to ask myself, how many times does 3 go into 2? Well, it doesn't. So I don't really put a 0 here, but we could if we wanted to. Then you ask yourself, how many times does 3 go into 23? Well, 3 goes into 23 7 times. And then we go, okay, 7 times 3 is 21. And then we subtract 23 minus 21 is 2. We bring down the 7. And we ask ourselves, how many times does 3 go into 27? We know that's 9 times. And we get a remainder of 0. So this would say, in using these long division things, we could say that 237 divided by 3 is equal to, so we're using this one here. The fraction is equal to the quotient plus the remainder out of the original denominator. Now that's not extremely necessary when we have 0 remainder. Or we could say that 237 is equal to the product of 79 and 3 plus 0 from my remainder. Now again, that's usually not how we write things, but when in polynomials, things look a little bit differently. So let's look at what it looks like as long division using polynomials. So we're going to do x minus 2 to see if it divides into 6x cubed minus 19x squared plus 16x minus 4. Now, one thing you have to do is when you're doing this problem, you have to make sure that all x values are taken care of in your bigger polynomial. So I have x cubed, x squared, x to the first, and no x's. Therefore, everything is taken care of. Then what you need to ask yourselves, how many times does x go into 6x cubed? But the other way that I ask this is, what can I multiply by x to get 6x cubed? Well, in order to get the 6, I need to multiply by 6. And in order to get the x cubed, I need to multiply by x squared. So then I do 6x squared times x, which gets 6x cubed, and 6x squared times negative 2, which gets negative 12x squared. And then we subtract. Now I'm going to make a big key out of this. This is subtraction. And negative 19 minus a negative 12 is like adding 12, so this becomes a negative 7x squared. And then we bring down the rest of our polynomial. And then the process begins again. What can I multiply by x to get negative 7x squared? Well, I need a negative 7 and another x. So I take a negative 7x, multiply by x minus 2, I get negative 7x squared. Negative 7x times a negative 2 is a plus 14x. And when I subtract, 16 minus 14 is 2. And then I ask myself one more time, what can I multiply by x to get a 2x? And I know that to be a plus 2. And I get 2x minus 4, and I subtract, I get 0. That means x minus 2 divides evenly into this cubic function. So we would write our answer as this polynomial. Let's call this f of x so I don't have to write this again. F of x is equal to x minus 2 times 6x squared minus 7x plus 2, and then add my remainder. Well, my remainder is 0, so again, it's not necessary, but I'm going to put it there to begin with. Or we could say that f of x divided by x minus 2 is equal to 6x squared minus 7x plus 2 plus my remainder out of x minus 2. All right, let's try another example here. So now we're going to take a quartic function and divide by a quadratic. So we're going to take x squared minus 2x plus 3 and divide into a quartic function. Now notice I don't have a cubic and I don't have a linear piece. So I need to add them in just in case. So I have x to the 4th plus 0x cubed plus 3x squared plus 0x plus 1. You never know, those zeros might be necessary. So I ask myself, what do I need to multiply by x squared to get x to the 4th? I know that to be x squared. So if I multiply x squared by the entire quadratic, I get x to the 4th minus 2x cubed plus 3x squared. So I subtract. 0 minus negative 2 is 2. 3 minus 3 is 0, so I need to, let's just keep it in there, plus a 0x squared. And I'm going to bring down all of my other pieces that are still there. Now the process continues. What do I have to multiply by x squared to get 2x cubed? I know that to be plus 2x. So I get 2x cubed minus 4x squared plus 6x when I multiply by 2x. Again, I subtract. I get 4x squared plus 6x plus 1. Sorry about that. That's a minus 6x because I'm subtracting. Then again, I ask myself, how can I make an x squared into a 4x squared? I just need a 4. I get 4x squared minus 8x plus 12. And when I subtract, those go away. And negative 6 minus negative 8 is 2x. And 1 minus 12 is negative 11. This is my remainder. So my remainder in this case is 2x minus 11. All right, I'm not going to write the answer in expanded form here just because I feel that we can do that. So let's go ahead and look at synthetic division. Now, synthetic division is a simplified version of long division, but it only works if you try to divide by a linear factor. So in our first example here, we divided by a linear factor, so we could have done synthetic division. But we could not have done synthetic division in the other one, in the second problem. So let's divide x squared plus 3x plus 5 by x plus 1. Notice that that is a linear factor. So we can use this idea of synthetic division. So here's what you need. This is what synthetic division looks like. It looks like a little box right here and a line straight across. The little box is the 0 for x plus 1. So whatever makes this thing 0. So in this case, it's going to be -1. The numbers that go across the top are your coefficients for your polynomial. So the number in front of x squared is a 1. The number in front of the 3 is a 3. And the number in front of the 5 is the 5, because that's the 5. Here's how synthetic division works. You drop the first number. Then you take 1 times -1 and get -1. And then you add straight down to get 2. Then you take -1 times 2 to get -2. You add straight down and get 3. And you would continue forever depending on how big of a problem you have. This number that you just got right here is your remainder. And these two numbers represent the thing that you get out across the top of your division. So the first number here is the constant, and the second number here is x. So in this case, it's 1x. If you had more, you would go to x squared, then you would go to x cubed. But in this case, the division is going to equal x plus 2 plus a remainder of 3 over the original division of x plus 1. So that would be my answer for this polynomial, this quadratic, divided by x plus 1. So let's try something else. Let's do synthetic division on this particular problem here. There's a reason I chose this one. I need to see what makes this thing 0. Well, I know that -3 makes it a 0, so that goes in my box. And then I need to write out all of my coefficients for all of my terms. But I need to pay attention that there is no x cubed term. So I need to put in a 0 if I don't have it. So my coefficients are 1, 0, -10, -2, and 4. So now the process continues, or begins again. Drop the 1, multiply by -3. Add. Multiply by -3. Oops, sorry, plus 9. Add. Multiply by -3 again. Add. Multiply by -3. Add. And I come down as a remainder of 1. So my answer here is constant, linear, quadratic, and cubic. So in this case, I have x to the third minus 3x squared minus x plus 1 plus the remainder over x plus 3, the original divisor. That would be my answer. All right, now there's something interesting with the remainder of your synthetic division. If you were to do synthetic division, or if you were to divide by a linear factor, then the remainder that you get is what you would get as if you were to plug it in. So let's say this. If I wanted to find f of -3, I could do synthetic division. Rather than just plugging it in, I think I could do synthetic division faster without screwing up the signs. So in order to find f of -3, I'm going to plug -3 into my box. I'm going to do 2, 0, -4, and 3. And I'm going to follow my synthetic division. So 2, -6, negative 618, 14, negative 42, and I get negative 39. That means f of negative 3 is equal to negative 39. And I didn't have to plug negative 3 cubed into my calculator. I didn't have to do any of that. And we can use this to determine if 2 or if a number is a 0 of the function by using synthetic division to see if f of 2 is equal to 0. So if my remainder is 0, then yes, 2 would be an x-intercept of my graph, or a 0 of my function. So I'm just going to do that. I'm going to go 2. Outside is 2, 7, negative 4, negative 27, and negative 18. And I really hope that this works, then comes out to a 0 down here. So drop it, multiply, add, multiply, add, multiply, negative 36 makes this a 9, which makes that an 18, which makes it 0. And since this comes out to 0, then yes, 2 is a 0 of f of x, if this was my function f of x. Well, looky there, that's going to be the final there for section 3.3. I'm going to leave you guys with that. You guys have your assignment sheets, and I will see you guys tomorrow.